Hello students! Today I'm going to be talking about a proof from the June 2023 Regents Administration Geometry Regents. So this problem, the last problem actually, there's probably like proofs every last problem. So I'll just debunk this. I'll say whatever whatever how I do this. Oh my, it's making me angry. Alright, quadrilateral ABCD. AB, segment AB is congruence to CD. AB parallel, so you can just put this parallel CD, and diagonal intersects, or diagonal AC, C intersects EF at G, and DE congruence to the F. That's our given. Now write that down. Now that's our given. We want to mark this up. How do we mark this up? Okay, what we are given: quadrilateral ABC. AB is congruent. AB is congruent to CD. I'll put whatever we have as red. AB is congruent to CD. AB congruent to CD. AB is parallel to CD. AB parallel to CD. Quadrilateral ABCD is diagonal AC intersects EF at G, intersects EF at G, okay, and DE is congruent to BF. That's our given. Now what we want to find is GF is the midpoint of EF. So we have to find G is the midpoint of EF. That's what we're trying to find. So how do we find that? We need to find EG is congruent to FG. Alright, now let's work with what we are given. So students, I want you to figure out what the first steps are. Now take a second. If you said we can prove parallel, you're right. ABCD is a parallelogram. Why this works is because whenever opposite sides have both parallel and congruency, you could say that parallelogram, parallel and congruence sides, opposite parallel congruence side. Okay, what next? Since we know it's a parallelogram, we can say I think this is the best option. AD, segment AD is congruent to BC. So AD CB is congruent to CB. Remember to put like lines over whatever, like for example this AD to show its segments. But I'm not gonna put that anymore because it's a waste of time. Ooh, waste of time. I have lots of time. Actually, I have minimal time because I am teaching and tutoring. AD is congruent to CB. Now let's mark that down. Let's see. So, this entire thing is congruent to this whatever. Alright, now we want to find, let's say we can use CPCTC. I can see the vision. EG to FG. We're going to use CPCTC to prove that they are congruent. So how do we get CPCTC? Yikes. Oh no, I know how to do it. First we want to prove that these two are congruent. How do we do that? We can use first, let's prove this. Parallelogram. Parallelogram. Opposite sides are congruent. Opposite sides are congruent. Oh, also make sure over here you can use the converse, right? It's because you're trying to find the parallelogram, so you want to use the converse. Alright, okay, 4. Since we know that opposite sides are congruent now, we can say if we want to find AE and CF are congruent, we do AE, segment AE plus DE is congruent. Oh wait, no, measure of E, whoa. Measure of AD is plus measure. Oh, whoa, what the? AE, okay. Measure of AE plus measure of DE is congruent, is equal, since its measures is equal to AD, is the measure of AD and the measure of AE, so CF plus measure of CF plus BF is equal to BC, right? AD, BC is equal to measure of BC. You could say this is the, what is this? Segment addition property. Okay, after we know that this is segment addition property, we can use transitive property to isolate AE and CF. But before we do that, we need to prove that the measure of AD is equal to measure of BC. Because if we don't do that, then we're just saying congruent, and that does not work. We need to put measure, because it says measure, and congruent. So let's say measure of AD is equal to measure of BC, and we can say definition of congruence. Definition of congruence. Now we can use transitive property. So since we know DE is equal to BF, okay, hold on, let me just, since we know DE is equal to BF, DE is equal to BF, we can cross these out, BF, and we know that AD is congruent to BC. Wait, no. Hold on. Add, for this, we need to add measure of EE is equal to measure of BF as well. Don't forget that, alright? If you skip through this, you're gonna make Professor Devin angry, bro. Okay, since we know that, we can do those. So now we can do this, right? We can say AE equals MD if this equals MC. So AE measure of AE is equal to measure of CF. Why this works, you can see if we draw it out, MAE plus measure of DE is equal to, since we know these are congruents, we can just say measure of AD. These two are congruents, so measure of this, which is also equal to this, so these are equal to each other, but we can also subtract these using subtraction property. Oh, wait. No, before we do those steps, we don't want to do those steps in such a fast pace, okay? Wait, keep, oh my goodness. Keep this. Keep this, measure of, what is it? DE is equal to measure of BF. Keep that. Now we can say, 6 measure of AE plus measure of DE is equal to measure of CF plus measure of BF. Now this is the transitive property. Transitive property. My dad thinks something is funny, but math is serious, guys. Do not let him fool you. Now we know that these two are congruent. Let me mark this out. These two are congruent to each other. These two are congruent to each other, right? So CF, yeah. Now we can use subtraction property. So subtraction property. We subtract both of these on both sides because they're equal to each other to make measure of AE is equal to the measure of CF. AE is congruent to CF now. Nice. Now we want to put this as AE is congruent to CF. Congruent to CF, since we want it back. Definition of congruence. Congruence. Nice. Now let's see, what else can we do? Alright, we can say that angle G is congruence to angle G. Wait, no, not that. AGE congruence to F. AGE CGF. Make sure to write it like the same order, because AGE goes into G and back here CGF, because A is supposed to be congruent to C. Remember to make that like proper order. So AGE reflexive property. Now we can mark that. Let's see. Mark that turquoise. I like that color. Yes, I guess. I like every color. I don't disgrace. Now let's see. What else can we add? Oh. Okay, so we can do angle, side. Yeah, we can do angle, side. Let's do that. If we want to find angle, side, we need to prove that AD is congruent to BC, or else it would not work. Because you know that these parallels can only do this one and this one, while these ones can do this one and this one. So let's say, so 10, 12, that's 12, so 10, holy, make me angry, what the fuck, Why? What are you doing? What is this? Hold on, technical difficulties. My fuck. Holy crap, students. That was that was kinda. Alright, 80. Moving on, 80 is parallel to CB. Because why? Because of the parallelogram. Opposite sides parallel. Theorem, maybe theorem. Parallel theorem. I think that's what it's called. Not sure. But now we can say that these are parallel. Make sure to mark it up like usual. Okay, we can now say that angle AGF AGE, that's E. Wait, no. DAC, that's a DAC, right? Yeah, DAC, angle DAC is congruent to DAC BCA. But why we can do that? Well, it's the parallel what's it called? Not a parallel, it's alternate interior angles theorem. Alternate interior angles theorem. Now that we have that, we can mark it. Angle. So angle right here. Then it goes here. Angle. Then it goes here. Angle, side. We have angle, side. Okay. Angle, side. Angle, side. Wait. Angle, side. Triangle. Congruence. Theorem. And after that, we can say CPCTC, corresponding parts of congruent triangles are congruent. If you really want to know that, so BGDGE. So, and then we can say definition of midpoints. Nice. Now let's find out what this all means. Angle, side, triangle, congruence, single. Oh, so triangle, AGE is congruent to triangle. Gotta match it up. Triangle AGE CG. What is that? BF. Oh, CGF. Alright, now CPCTC, we can say that segments EG congruent to FG, and now we can say G is a midpoint. Definition of midpoints. Okay, let's check our work. Quadrilateral, parallelogram. There's a these. It's a parallelogram. AD congruent to CB. AE is angle AE. Oh no. This is not measure of angle AE. This is just measure DE. Okay. Measured AE is DE plus DE. Yada. And measure. Now we can do measures. Now we can do congruence. congruent, parallel. Okay, nice. That's great. Alright. And hope you enjoyed that video. Make sure to like, subscribe, comment down below what you would like me to do next. Because this, I hope this helps with regions. If not, well, I might get fired, I might get butt fucked, I might get gang banged by black people. I mean, it's whatever. It's on a daily basis anyway, so it's not new to me at all. But Professor Devin really hopes you enjoyed this learning session, gooning session. I hope you enjoyed it. Next time, maybe I'll do one. Not sure. Like, regions is in 2 days. Like, if you're reading this, it's probably like in 1 day. I mean, watching this, reading this. Am I sped? Yes, I am sped. Deal with it.